Okay, the multimole relationship lab is going to ask you to do a chemical reaction. You're going to add solid copper to a solution of silver ions. They're basically going to swap places. It's a single replacement reaction, and you're going to get as products the copper dissolved in the solution and silver solid. So we're going to collect enough experimental data to find the mole ratio here between the copper and the silver, and since the mole ratio is what we find as coefficients in a balanced equation, we'll then be able to write the balanced equation with the numbers that we find. There's not a lot of data to collect. This lab, the procedure is very short. It happens instantly. That's not really how the reaction would occur if we did it in the lab. In reality, it would take about several hours or a day for the reaction to complete. You will know the mass of copper because you're told how much of it to use in the procedure. The only other piece of information that we need to proceed with the calculations is the mass of silver, and that's actually the product that we're making. So at the end, when you have now a beaker with some silver in it, you'll need to know the mass of just the silver. Late Night Labs refers to it as the dry silver, which means you've poured off any solution and you've also subtracted out the mass of the empty beaker. So don't forget to do that. We don't want to report the mass of a beaker here. We want just what's inside the beaker. So it should only be a few grams, 3 or 4 grams. That's all we need to then proceed with the calculations. Each of those masses, the mass of copper, which you're going to know, and the mass of silver, which you will also know, each of those needs to be converted to moles. So we know that 1 mole of copper is about 63.5 grams, and we know that 1 mole of silver is about 107.9 grams. So we're using here the molar mass that we're learning about to do those conversions. So this will tell me how many moles of copper I reacted, and this will tell me how many moles of silver I produced. It's a good idea because this is not the end of the calculation. We should probably keep a generous amount of significant figures here. So don't round these values off. Keep several digits here. I don't know, 5 or 6 digits would be good. Once you have those mole values, we are going to actually find that these are going to be decimal numbers. And so I'm just going to give you an example of what they might look like. These are made up. You'll actually have different numbers, but let's just pretend like the copper value comes out to be 0.0035 and the silver comes out to be 0.0105. Okay, so what do we do with that? We obviously did the reaction on a very small scale. So how can I get this converted to coefficients that I might likely see when I look at a balanced equation? And when I look at a balanced equation, I generally see whole number values here. So what you would do, a simple way to do it, is to take your mole values, look at both of them, and decide which one is smaller. Of course, this one is the smaller one, and we can take it and divide it into both of them. So obviously it divides into itself once, and it divides into the larger one about 3 times. So what I've done is taken 2 fractional coefficients and converted them to whole number coefficients by dividing both by the smaller value. These now become my whole number mole ratio. So I would, if I got 1 and 3 here, 1 for copper, 3 for silver, that would actually tell me that my balanced equation looks 1 for copper, 3 for silver, 1 for copper. Everywhere you see copper, a 1, and everywhere you see silver, a 3. Okay, so this is again with just made up numbers. You'll use the ones that you actually find from your mass calculation. Another point that I wanted to bring up is just the question number 5, just to go over what it's asking. Once you have your balanced equation with copper, whatever it turns out to be, in question 5, pretend like the reaction was not done with copper but magnesium instead. So rewrite the very same equation but with magnesium, and the question asks, if you produce 1 gram of silver right here, how much magnesium must have been used? And this is just a straight stoichiometry question. It's a good time to review that maybe. 1 gram of silver can be converted to moles. And then moles of silver can be converted to moles of magnesium. The mole ratio goes right here that you find. And then, of course, moles of magnesium can be converted back to grams. So this is the basic stoichiometry problem that we're looking at in Chapter 6, converting to moles, using a mole ratio, and converting back to grams of some other substance in the equation. So question 5 is just asking you to do a stoichiometry problem like this.